Bismillah ar-Rahman ar-Rahim. This video will concern hello everybody. This video will concern the parity, which means if the function is even or odd, and the periodicity, if it admits a period or a perimeter type. I will explain later what we mean by these terms. First of all, before to check if your function g of x is equal to minus g of x or minus x, or g of minus x is equal to g of x, or g of minus x is equal to g of x. Before checking, usually we use this symbols, which is the same. Before checking these two possible equations, we have first of all to check the very important thing, that the domain of definition should be symmetric. This is the most important pre-information or property that the function should verify before checking these two well-known equations. Let us start with f1. We will study first parity, which means even or add or not at all. Then we will start periodicity of these 8 functions. For f1, the domain of definition is R, so it is symmetric. Then f1 of minus x equal minus 3x minus x power 3 plus 3x power 7. We are able to do this because here the powers are odd, which is equal to minus f1 of x. This means that f1 is odd. It is odd because it verifies this equation and the symmetry of the domain of definition. f2, the f2 is equal, since we have square, so the domain of definition is equal to R. And what we have f2 of minus x. We get here 1 plus x and here 1 minus x square. This is equal to f2 of x for all x in its domain of definition. So f2 is even. For all x here, for all x in the domain of definition, and here for all x in the domain of definition. How about f3? The f3 is equal to s, so this is symmetric. Then for all x in the domain of definition of 3, we have f of minus x equal to 3. This means that is equal to f of x. This means what? This means that f3 is even. How about f4? The f4 is equal to 0 plus infinity Here we will stop. Stop here. Stop. Stop trying. Why? Because DF isn't at all symmetric. So we stop. It is neither even nor odd. How about F6? How about F6? F6 is equal to cosine F6 of x is equal to sine x divided by cosine x. Cosine x equal to the domain of definition. Domain of definition is equal to x in R, such that cosine x is different of 0, and cosine x is equal to 0. This is equivalent to x is equal to k pi, and k is in z. So the domain of definition of 6 is equal to R minus k pi, k in z, which is symmetric. Then we can speak about parity. So we are sure that the domain of tangent is symmetric. Then for all x in df6, we have f6 minus x. This is odd and this is even. So this is equal to f6 of x. This means that it is odd. It is odd. How about f7? df7, this is equal to x which belongs to R, such that what? Such that 2 cosine x minus 1 is different of 0. Let us solve this equation. 2 cosine x minus 1 equal to 0. This means that cosine x equal to 1/2. And the angles that makes cosine x equal to 1/2, I think that we have 2 pi divided by 3 and minus pi divided by 3. This means that the domain of definition of f7, so df7, this is equal to R minus what? Minus pi divided by 3 plus 2k pi, and minus pi divided by 3 plus 2k pi, such that k belongs to z, which is symmetric. This domain is symmetric. You can please take k equal to 0, so we will find quickly. K equal to 0, we have here 0, here we have pi divided by 3, and here we have minus pi divided by 3. K equal to 1, we have 7, so we have here 7 pi divided by 3. For this one, k equal to 1, we have 5 pi divided by 3, and here we have minus 5 pi divided by 3, here we have minus 7 pi divided by 3, and so on. They are symmetric, the domain is symmetric with respect to 0, sure. So we can discuss the parity of f7. Actually, f7 is even. Why? Because cosine x is even. We have f7 of minus x. This is equal to 1 divided by 2 cosine minus x, which is cosine x minus 1. So this is equal to f7 of x. This means that f7 for all x in the f7. This means that This means that f7 is a even function. How about the last one, f8? About f8, the domain of definition of f8 is actually equal to r, but it is not even nor odd. Why? Because we can just check here. We guess, we think that it is not even, nor it is never even nor odd. We can check. We can take, for example, x equal to minus 1 dot 9. We can just 1 dot 9. f8 of minus 1, this is equal to what? This is equal to minus 1 dot 9 minus, and the integer part of minus 1 9 is minus 2. This is equal to 0, 0.1. 0.1, and from another side, f of 1 minus 9. This is equal to 1 minus 9 minus the integer part of 1 minus 9, just 1 minus 9, which is 1, which is equal to 7. We haven't f8 of minus 1 minus 9. This is different of f of 1 minus 9, and f8 of minus 1 minus 9 is different of minus f of 1 minus 9. Just an example. It is enough to show that it is neither even nor odd. Yeah, let me check once again. We have x equal to 1.9, so f8 of minus 1.9 is equal to minus 1 dot, minus the integer part of minus 1.9 is minus 2. This is equal to 0.1, and f of 1 minus 1.9, this is equal to 1.9 minus the integer part of 1.9, which is equal to 1. So this is true. This finish this subject about parity. I think that I will let the periodicity for the next video. Thank you very much. See you next time.